People in general are interested in science and applied science, but there is always this invisible wall which doesn't let them learn because they encounter graphs like this, questions like this, and this. This scares some of them and they walk away. But what if instead of scary equations and graphs, we learn stuff through stupid drawings and animations? This is why I made a YouTube channel Quantessy where I plan to explain stuff from refrigeration cycles to naked singularities. Make sure to check it out, and if you like it, don't forget to subscribe. And special thanks to blackpenredpen for promoting my channel for free.
Okay, in this video we are going to compare the Newton's method and the Euler's method, and we are going to use both methods to compute square root of 2, and each one will just do 5 steps, so that's how we can be fair, and in the end we'll see which method will give us a better answer. And also, I have videos on Newton's method and also Euler's method in details, so be sure you guys go check them out. In this video, I'm not going to derive the formulas, but I will talk about the idea. That's the most interesting part. So let's start with Newton's method first. For Newton's method, the idea is that we're trying to approximate a zero of a function. So if you want to get square root of 2, let's just do some scratch work. I want x to be square root of 2. Square both sides, we get x squared, and that's equal to 2, and then we can subtract 2 on both sides. So we're talking about x squared minus 2 equals 0. So this equation, of course, has a solution, square root of 2, right? And this is what we need. And of course, let's talk about the graph right here. Let's say I want to graph this for you guys, which is like that. And you have to start off with a function. And I will just pick this, namely f of x, to be x squared minus 2 to be my function. And what you need next is that you need the derivative as well. So f prime of x, this is really nice. Differentiate that, you just get 2x. And you want to pick a starting point, starting x value. And usually you just kind of do it by guess and check, but of course you can do better. You can do the intermediate value theorem, meaning that if you plug in 1 in here, you get 1 squared minus 2, which is negative 1, which is down here. If you plug in 2 here, you get positive 2, so it's up here. So you know the root has to be somewhere in the middle. And I will actually just start, and I will call that starting value x naught to be 1. So I will start with 1, and then hopefully I can get to there. All right? So this is the target that we are trying to hit. This is the square root of 2. So that's pretty much the idea. And of course, here is the formula that we are going to use. We will have the formula which is xn, this is equal to the previous x value, and then we subtract the value of the function at the previous x value divided by the derivative of the function at that previous x value, just like that. So of course, now we can just plug in the values and things like that. And before we do any of that, let's maybe also talk about Euler's method. For Euler's method, the idea is that you want to start with a curve. But technically, you don't know what a curve is. Sometimes it's maybe hard to do. So you want to start with a differential equation. But of course, we're talking about square root of 2. So the curve is square root of x. So I will just draw this for you guys. Square root of x, of course, looks like this. Y equals square root of x. Well, what we have to consider is the following. I need a differential equation, dy dx. If you look at that, of course, you know dy dx is just 1 over 2 square root of x. That's the derivative of square root of x. But I'm not going to use square root of x, because if I do that, it's kind of cheating. If I can compute 1 over 2 square root of whatever, I can do square root of x already. But the beauty of this is that, look, square root of x is exactly y. In other words, dy dx is the same as 1 over 2. This right here is just the y. So you start with a differential equation right here. I will say dy dx, and we will just put this down, 1 over 2y. Okay? This right here has a special notation. We call this to be f of xy. And this right here is also related to the slope field. You guys can also check that out. And this is pretty much going to tell you the slope, the direction. And the idea of the Euler's method is that hopefully you also have an initial point. Well, we are talking about square root of x. Let's pick something easy. And of course, let's be fair, I'm going to pick 1 and 1. Right? So I will say my x naught is 1 and then y naught is also 1. That means I will be right here. And in order to get to where I want, of course, I need to get to when x is equal to 2. So that I can end up with this, which is square root of 2. And here is my target. So it's very different style. And the formula that we're going to use right here is that we have to focus on the y values. I will tell you yn is equal to the previous y value. And then we are going to add, well, we also have to talk about the h, which is the step size. Let me just write this down, and then we multiply by f of xn minus 1, yn minus 1, meaning it's like the slope at that previous point. Now, what is h? Well, we decide. In this case, h is we decide. And I will just say, let the step size, and because I'm trying to get to square root of 2, that's when you go from x is equal to 1 to 2. And I want to do it 5 times, so 1, right, because that's the difference, is 1, divided by 5 is 0.2. So I will say the step size h is 0.2. This right here, the smaller the step size, the better. But, you know, once you pick this right here, you have to do it exactly 5 times in order to get an approximation for square root of 2. On the other hand, though, once you start with this, if you do it as many times as you want, if you do it 100 times, of course, that approximation would be even better than if you just do it like 3 times. So that's one of the difference between Newton's method versus Euler's method. This right here, the idea is that you let n goes to infinity. Ideally speaking, you can hit the nice value of square root of 2, but you have to make h to be as small as possible and then do a lot. Imagine if you have 0.01, you have to do it 100 times in order to get to square root of 2, because you have to take 100 steps in order to get to x is equal to 2. All right, let's put this in action. So here we go. x0 is 1, so I will say here we go, x1 is equal to the previous x value, which is 1, and then we are going to minus. Well, I'm just going to plug in 1 into here and then plug in 1 into here. So I will do it for you guys. This is just 1 square minus 2 over 2 times 1, like that. And of course, you can just work this out. This is actually precisely equal to 1.5, right? And then that's the first step, yeah? And then the next one, x2, you look at the previous x value, which is 1.5. Well, unfortunately, I cannot do this in my head. I'm looking at the screen for the answer. I'm not going to run. If you run, it's going to be 7 right here, but you know, I'm not going to run. Just cut off like that. All right, so now x3. And you can actually do this on Excel or Number, depending on what kind of computer that you have. But you know, you can program this. Anyway, the answer to this is about 1.41421. And in fact, let me also put down 5 after that, right? Well, next, we pretty much do the same thing. 1.4142135. Okay, in fact, you can see that you get a 1.41421 already. And if you actually do this again, you get approximately pretty much the same answer. So you can actually stop because the next one you do it is pretty much the same thing. So based on Newton's method, we are saying that this is our approximation for square root of 2, right? So this is for Team Newton. And before you guys continue watching this part right here, leave a comment down below and let me know. Do you think that Newton is going to win or Euler is going to beat Newton? Leave a comment down below now. Okay, so here we go. Let's do the Euler's method. Starting from your x0 and y0 is 1 and 1. And this is the setup in my previous video. I will do the same thing too. So you have to keep track. x0 is 1 and y0 is also 1, okay? And then continue. x1, you have to keep track of where you are at. So you are moving 0.2 away and you are going to go up. And by the way, the reason I know it's 1 and 1 is because, of course, you knew the function, so square root of 1 is 1. If you solve this differential equation, you do get that. Okay, enough saying. Right here, x1 is just going to be 1.2 because you move 0.2 away. And then, here we go. y1 is equal to the previous y value, which is 1, plus the step size, which is 0.2. And for this part, what we do is you just plug in the previous x and y value into your differential equation. And depends if you have this right here based on x and y, or just x or just y. In this case, it's just y, right? Based on the y right here. So I just need to worry about plugging this one into the y right here. The x doesn't matter in this case. So I will have 1 over 2 times 1, like this. And once again, you just work this out. This is only 1.1, right? All right, next, you are going to keep track of the x value as well. This is going to be 1.4 because once again, you add 0.2 to the x value. And now let's see y2. Look at the previous y value, which is 1.1, and you add it with the h, which is 0.2. And then you are going to plug in the previous y value into your dy dx. So it's 1 over 2 times 1.1 now. Well, this is approximately, yeah, it's kind of weird, but let's keep going. Okay, here we go. Next one, 1.3533. All right, last one actually, x5. And in fact, if you want to get to square root of 2, you have to stop right here because the x value is precisely at 2 now. Once again, if you want to have a better approximation, you have to decrease the step size, and you have to do a lot more. Okay, Wi-Fi, 1.4. I really have to disappoint you. It's 1.4272. And if you want more digits, it's 0.9. After 5 times, well, this is overestimating when you are using Euler's method. This is really good. In fact, it was really good when you do it 1, 2, 3 times already. But anyway, leave a comment down below and let me know. And if you have any other questions, leave a comment down below and let me know. And if you're new to my channel, please subscribe and please recommend me to your teachers, friends, students, parents, kids, cats, crocodiles, raccoons, birds, your Michael Jordan, LeBron James, Kobe Bryant. And as always, that's it.